So here you can see that gathering up and that box taping type effect there, that pinch unloading that we've created just by doing that pinch within the tape there as we've come through. You can see the resting position of the hand has changed as well because of that resistance to flexion. Okay. Now we might want to increase the amount of the boxing that we've got going on through here, and we can do that really nicely. Again, we do it quite differently to what we would do with a kinesiology tape. So with your kinesiology tapes, you're often going for that space creation type of idea where you're starting in the middle, tearing it, putting some tension on either side and allowing the recoil of the tape to lift those outer layers of the skin to create the space and so on. Now with dynamic taping, what we're doing is more what you may have done traditionally with a rigid athletic tape, some of your McConnell type techniques, where we're really trying to box up all of the soft tissue. So actually even in a lengthened position, everything is boxed up and we've got this big soft spongy area of all of the soft tissue, not just lifting those outer layers of the skin to create the space. So the way that we do that is not to start in the middle. If we start in the middle, again, that makes it very, very difficult. Again, we want them in a short position, that soft tissue in a short position, so it's relaxed and I can really bunch it up nicely. So we're going to put the wrist and fingers in some extension again to take the stretch off and allow me to box up all of this soft tissue, or even bending the elbow a bit to create a bit of softness or a bit of shortening on our brachioradialis as well. I don't want to start here and come down either side because that's just going to give me lifting of the skin. I want to start on one end. I want to then use my fingers to really pull all of that soft tissue together to create that boxing effect. Now there are lots of ways that you can do it. You can either do it as an X straight over, say, that lateral epicondyle. Often that can feel very, very nice in, say, your tennis elbow type of population. Or you might want to create above and below. Often a V coming from above and below can create a really nice effect. So the way we do it is quite different. We put one end on first and we anchor through the tape. We then use our fingers to pull up all of this soft tissue, and I'm bringing it back up in this direction, pulling it all up, putting my tension on the tape, and then again my anchor without any tension again. And you can see how much additional boxing I get from doing that. Now notice there's no convolutions in the tape. It's all boxing the soft tissue up first and then holding it in position using that strong recoil of the tape. If I wanted to increase it further, I could bring in another one on this side and really box it all up around there. So let's just have a quick look at that. So now if we do the same again, but this time above, again we're going to start at one end, not in the middle. I've got them in the short position once again. I'm going to use my thumb. This time I'm going to swap my hands over. Use my thumb. I'm going to pull all of this soft tissue using my fingers back in this direction to bunch it all up. Take up my tension but keep my anchor point pressure, and then relax again. So that I get this really nice unloading of all of that soft tissue through that entire region. And that can be useful for your tendinopathies. We know that they're brought on most rapidly from a combination of tensile and compressive loading. So we can do some work to reduce that overuse or tensile load, and we can box up around some of them where they're nice and superficial to reduce some of that extrinsic compressive load. But also our neural tissue, we know that when it's sensitized, it doesn't like stretch. It also becomes allodynic, or it doesn't like that pressure. So for some nerves where they're relatively superficial, we may be able to get in and box up around all that soft tissue around there to reduce some of that extrinsic tissue pressure that may then continue to sensitize that nerve and keep driving that process. Muscle tears obviously is a big one. We know that by boxing up, the work by Hug et al. In 2014 showed boxing up in the quadriceps muscle reduces the mechanical stress on those tissues even under contraction, except for when it was in its absolute shortest. So for muscle tears we can again do some of the work, but we can also come in and box up to reduce that strain, that mechanical stress on those muscle fibers themselves by doing this boxing up. Now it's not lifting skin, creating space, it's actually pulling everything together and holding it there using that strong recoil of the tape. So here we can see how effectively that's boxed up all of that soft tissue there. If we compare what's happening down here to what's happening here, very, very different, where we've really gathered everything together to take some of that soft tissue pressure off.